So we are starting with quadratic function, and then we want to rewrite the expression or the equation. Okay, so now let's start with quadratic let's start with, let me write the general equation of a quadratic, and then you will tell me the methods that we can use to solve this equation. So I will write the general expression, and your role will be to tell me different ways we can use in order to solve the quadratic equation. Okay, so that's how we are going to start. So I'm going to write, so this is the general equation of quadratic. Another way of saying it is any equation that looks like that is a quadratic equation. That's a simple way of saying it. Okay, so now let's give me an example. Give me an example of this type of equation. I'm waiting, ladies and gentlemen.
Can you repeat what you said?
Give me an example of a quadratic equation. I have written the general form, so give me a specific example.
5x squared plus 3x plus...
Hold on, please. 5x squared plus 3x
plus 2.
Plus 2.
Oh, you want to equal something? Okay.
Yeah, equal to 0. Yes. So we have to write it this way. Or if you don't want to write it this way, you will write it as f of x, which is a function, equal to 5x squared plus 3x plus 2. It's a function. All right? That's why it's called quadratic function. Okay, so that's a typical example. Now, so that means looking at just our general equation and this specific example that we have here, it follows that the coefficient A is equal to 5 and B is equal to 3 and C is equal to 2. That's what it means. Okay, so that's one aspect of it. Now let's articulate different methods of solving quadratic equations. So I can write it as methods. Okay, so give me the list of methods that you can use to solve quadratic equations. A, B, C, D. Yeah, go ahead, please. I'm waiting. What are the methods that you have used in the past to solve a quadratic equation?
Is factoring.
Factoring is one of them. Thank you. Factoring, or you can call it factorization. Okay, next, another method you may have used in solving quadratic equations.
Completing the square.
Okay, completing the square. Thank you. Completing the square. And then another method you have used is
the quadratic formula.
Quadratic formula. Thank you. Quadratic formula. And next is, starts with G.
Graphing.
Graphing. Okay, so at this stage of your mathematics learning, you have to know how to use these three methods to solve any quadratic equation. Okay, so now while we were doing all these algebra 2, bridging the gap, we tried graphing, we tried quadratic formula, and we tried factoring. So today we are going to start with completing the square. Okay, so today we are going to start with completing the square. Now the good news is completing the square is what is used in deriving the quadratic formula. So completing the square is the method that is used in deriving the quadratic formula. So, and that is our starting point. Because we were dealing with rewriting of expression, so we have to do completing the square. We have to use completing the square to derive our quadratic formula, the formula that you use while solving quadratic equations. So let me write it by the side. So this formula, just in case, I need help anyway. X equal to minus B. Yeah, go ahead. Tell me the rest of the numbers. Plus or minus square root of B squared minus 4AC divided by 2A. So that's the quadratic equation formula. So this formula, like I said, let me repeat one more time. Quadratic equation for completing the square is used to get this formula. So now let's see. And going forward, this particular section of this lesson now is very important. So you need to pay very close attention. So you may have seen it before and you may not. And most of you, I believe, probably haven't done it before. So that's why you need to pay close attention now. So our general equation is ax squared plus bx plus c equal to 0. Okay? So let's first of all before I derive the formula, let us use a very simple formula, a very simple quadratic equation, and then we complete the square. And then after completing the square, then you will see, how it is going to work. So let's see. If we have this expression, watch, 1x squared plus 6x equal to 0. This expression I have written right now, it is not a complete square. It is not a complete square. A square is, why it is called a square? A square is, if you just sketch a little square, a square means the left side, one side is the other. If this is 3, here is going to be 3. If this is 4, here is going to be 4. If this is 5, this side is going to be 5. That's a square. So if we factor this number right now, if we factor this expression, we are going to have x bracket x plus 6. So it is not a perfect square. So in order to make it a perfect square, here's what you do. So you can indicate not a perfect square. However, we can make this a perfect square. We can make this one a perfect square. Now here's what you can do in order to make it a perfect square. So look at the coefficient of x squared. So let me rewrite it. The coefficient here is 1 of x squared, which is a is equal to 1 and b is equal to 6. So now look at the coefficient of x squared. If it is not 1, then divide everything by this coefficient. For example, if this were to be 2, then divide everything by 2 to eliminate it. Okay, but since it is 1, so it made our life easier. So now look at this one. Divide it by 2. Divide b by 2 and then square it and add it to both sides and add it. Let me just put it this way, add it. So now what does that mean? 6 divided by 2 is 3. So 6 divided by 2 is 3. Then 3 squared is 9. Then add it to this expression. So you are adding x squared plus 6x plus 9 equal to 0. Okay, so now if you factor this, you are going to have, let me just write the factor. You are going to have x plus 3 bracket x plus 3, and that's equal to 0. So you can try it. You may use distributive property to open it. So now this becomes a perfect square. All right. So this becomes a perfect square, which is x plus 3 and then x plus 3 right here. So this is a perfect square right now. So that's what we are trying to achieve in completing the square. So usually you are going to get an expression that when you factor it, you will not have a perfect square. But our goal is to make it a perfect square. And that is what we have just done. So having said that, now let's get back to our expression, the real expression of, let's get back to the real expression. Any questions so far before? Because this is where it might get a little bit complicated. Any questions so far?
Can you scroll back a little bit?
Yes, I will, but I need questions.
I have a question.
Yes, go ahead with the question. Yes.
So for the part where you said divide by 2, where are we getting the 2 from since A is 1?
Okay, good. We are getting it actually. We are getting it actually from nowhere. It's just one technique that you can use, but it is mathematically correct. So it is that 2 is a number that you can use in order to make it a perfect square. For example, let me use this thing as an example. Let me draw another object now. If I draw this and say that this is 7 and this is 5, and I want to create a perfect square out of these, what do you think I should do? If you want to create a perfect square out of this, you have to either add 2 to this to make it 7, or you take away 2 from this to make it 5. Am I making sense?
Yes.
Yes. So that's it's just a technique. All right. So, and we are going to use it now. So when you say divide by 2, the 2 is just somebody has already figured it out. So we are just trying to let you know that that 2 actually works. All right.
Okay.
So, all right. So let's now move on. Let's now move on with the real expression. I'm going to use it again, but I'm going to use it now in, you know, all these bunch of numbers expressions. So let me rewrite the expression again. Ax squared plus bx plus c equal to 0. That's the general expression of a quadratic. Please pay close attention here. This one is very important. So now we have to make sure that the coefficient of x squared is 1. That's the first step. So if you like, you can write it down. Make sure that the coefficient of, let me erase this. I believe he's taking the note. The coefficient of x squared is equal to 1. If it is not 1, you have to force it to be 1. How do you make it by force to be 1? So divide all the terms by that coefficient. So if we divide ax squared divided by a plus b divided by a x plus c divided by a equal to 0 divided by a. That's how you can make it to be 1, because a divided by a is 1. True or false?
True.
Okay, good. And so our right side is 0. So this one becomes c over a plus this one becomes b over a x, and this one becomes x squared. So we have a coefficient that is 1. Now, next step, transfer this term to the right side. So transfer the c over a term to right hand side. Okay, so let's do that. See, I'm giving you concrete steps. You can call this step 1, you can call this step 2, and then let's do the step 2. So we are going to rewrite our expression to say x squared plus b over a x, and then equal to
Get to class. And I hear iCarly.
Okay, so when you transfer positive to the right side, it becomes what?
Negative.
Negative. So it becomes negative. So write your negative c over a. So now you can see that this very expression, let me just underline it temporarily. This very expression is beginning to look like this very expression. This one. Is it not true? Okay. So next step is, I'll write step 3. Divide the coefficient of x by 2. Then square the result and then add it to both sides. Add it to both sides. This is a very huge step. Once you master this particular step, you are done. Okay, so now let's start. Let's divide the coefficient of x squared. The coefficient of x, rather. The coefficient of x is b over a. So let's just say b over a divided by 2, right? So that's going to give us, we are going to use a primary school method that is called keep, change, flip. So we are going to keep this one, b over a. We change this one to multiplication, and then we flip 2 over 1, 1 over 2. Once we do that, we are going to have that it is b over 2a. That's the result. So this is the result. So it says square the result. So we are going to have b over 2a whole squared. All right. So now let's expand it. Let's expand it. So which is b times b divided by 2a times 2a. So b times b is what? B squared. And then 2 times 2 is 4. A times a is 4a squared. Okay, we have squared it. And then the third step says add it to both sides. So add it here and also add it here. Okay, so that's what we are going to do now. So we are coming here and saying x squared plus b over ax, then plus this result, b squared over 4a squared equal to, then we're adding it this side as well. So we're adding b squared over 4a squared minus c over a. Okay, so now our role right now is to simplify. From what we have just done, we have created a perfect square on the left side. So we have created a perfect square on the left side, and then we have to simplify the right side. So now what is the perfect square on the left side? Here's the perfect square. So now this number is very, very important. This number, you know, as I is in now. So just say x plus b over 2a whole squared. That's a perfect square right there. Because when you open this parenthesis, it's going to give you this. It's going to give you this one. So now that's equal to, then we have to simplify this using fraction. The same fraction you learned in 7th grade or 8th grade. That's what we are going to use now. So that would be, look at this, lowest common denominator. So what's the lowest common denominator of 4a squared and a? It should be 4a squared anyway. So now we can divide 4a squared divided by 4a squared will give us 1. So 1 times b squared will give us b squared. Then minus 4a squared divided by a. So we are going to have 4a. 4a times c will give us 4ac. Okay? All right. Now, in order to solve for c, no, not c, x. In order to solve for x, which is what we are trying to accomplish, we have to square both sides, square root both sides. So you can say at this stage, step, how many? Step 4. Step 4. So is square root both sides. Square root both sides. So now when you do that, you just write in square
Mr.
one.
Maple,
Yes.
I don't understand.
At what stage?
Step 3.
Okay. I will go over step 3, but let me finish writing this very statement, then I'll go over to step 3, okay?
Okay.
So let me just allow me to write this statement now so that I won't forget. Then I'll go to step 3. So I say square root both sides. So you're square rooting x plus b over 2a whole squared equal to plus or minus square root this side, which is b squared minus 4ac over 4a squared. Okay, So now let me get back to step 3. Actually, in the real step 3 it's a little bit confusing, but you need to practice it before you can get it. Okay, we are after what we are doing right now, we are going to use real numbers. We are going to use real numbers to solve using completing of square. But let's get the formula first. Let's get the first. So it says divide coefficient of x by 2. So here is coefficient of x here. This is it. I'm going to circle it. Here's the coefficient of x here. Say divided by 2.
Let me see the bottom.
Yes, I will come to the bottom, but let me explain step 3 first of all again. So divide the coefficient of x by 2. So this is the coefficient of x. B divided by a is the coefficient of x, and I'm dividing it by 2. So it's like use this type of expression. If you're dividing 4 over 3 divided by 2, what are you supposed to do? You keep this 4 over 3, you change this multiplication, and you flip this 1 over 2, which gives you 4 over 6, which gives you 1 over 3. That's exactly what I did here. So I use keep, change, flip, divided it by 2, and then I ended up getting b over 2a. And the instruction still says, then square the result. So that's where I'm squaring it right here. B over 2a whole squared is b times b divided by 2a times 2a. And when you perform the square itself, it's going to give you b squared over 2a squared. And then the last step in that step number 3 says add it to both sides. This is where I'm now adding it. I hope you can see my mouse. I'm adding it on the left. I'm also adding it on the right. Okay, so now once you perform that division, square it, and add it to both sides, then it becomes a perfect square. So this is a perfect square now, because when you factorize this, if you factorize this, you are going to get this. If you factorize this, you are going to get this. And that's what makes it a perfect square. All right? So now let's continue. We have about 3 more steps to go. 3 more. So if you square root this number, you are going to get the same number inside. So just write it. X plus b over 2a is equal to plus or minus. Then you can square root the numerator and square root the denominator. So when you square root the numerator, that's going to give you square root of b squared minus 4ac. If you square root the denominator, it's going to give you 2a. All right, so we have square root of b squared minus 4ac divided by 2a. So we have 2 more steps now. 2 more steps. So now let's get to the next step. So we transfer this to the right side. So that's going to give us x equal to, when you transfer a number, the sign changes. So you are going to have negative b over 2a plus or minus square root of b squared minus 4ac divided by 2a. So we have 1 more step. 1 more step. So now we will still use the same fractional method of solving fraction. So you can see that the numerator, no, I'm sorry, the denominator is the same, common denominator. So you just write divide by 2a. 2a divided by 2a is 1. 1 times negative b is negative b. Then you retain your sign, plus or minus. Then 2a divided by 2a is 1. 1 times square root of b squared minus 4ac is the same thing, which is b squared minus 4ac. And that's equal to x. And this is your quadratic equation formula. So that's actually 4ac, not 4a, 4ac. You see? So when somebody writes you quadratic equation formula, you can tell the person, oh, I know how to get it.